Hi, and welcome to day 4 of Intro to Trig Part 2. I know I said I wouldn't do this before, have it all written out for you, but when I was recording this video the other day, somehow it didn't save and it had some issues with it. So instead of my redoing the whole thing, I just thought I'd kind of go through it with you. Talking about the remaining trig functions today. And just as an introduction and review, sine is equal to 1 over cosecant. Cosine theta is equal to 1 over secant. Tangent theta is equal to sine theta over cosine theta, or 1 over cotangent theta. Cosecant is equal to 1 over sine theta. Secant is equal to 1 over cosine theta, or cotangent is equal to 1 over tangent theta, or cosine theta over sine theta. That's just a little review. And when I have number 11 here, that just means it's like number 11 on the classwork that you're going to be doing in class. Write each of the 5 remaining trig functions in terms of sine theta. We've seen these directions before, except it usually says sine and or cosine. This time it's just sine theta. I only want my answers in terms of sine theta, meaning I can't have a cosine or a tangent or any other trig function in my answer. So cosine theta, in order to get it in terms of sine, we have to use the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And I need to get cosine alone, so I'm going to subtract sine squared theta from both sides. So that's why I have 1 minus sine squared theta. And then to get cosine to not be cosine squared, I take the square root of both sides. And when I do that, I get cosine squared theta equals, that's supposed to be plus or minus, the square root of 1 minus sine squared theta. Tangent is sine theta over cosine theta. And I can't have a cosine theta in my answer. So in place of cosine theta, I'm taking this plus or minus the square root of 1 minus sine squared theta, and I'm going to replace it. So it's a substitution. So it becomes sine over plus or minus the square root of 1 minus sine squared theta. Cosecant is easy because that's just 1 over sine theta. I don't have to do any kind of funny substitutions there. Secant is 1 over cosine theta. And like before, anytime we see a cosine theta, we're going to put this into the denominator. So it's 1 over plus or minus the square root of 1 minus sine squared theta. And for cotangent theta, I have cosine theta over sine theta. And again, in place of cosine, I put plus or minus square root of 1 minus sine squared theta over sine. Most of the time, the directions will have you to put it in terms of sine and or cosine. But every once in a while, they want you to do it in terms of sine or in terms of cosine. Number 11 on the in-class work is going to be putting everything in terms of cosine theta instead of sine theta. So the process is exactly the same, except instead of trying to get cosine alone, your goal is to get sine alone first. All right, next page. As a little review, a little reminder, sine is opposite over hypotenuse. H. Cosine is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is hypotenuse over opposite because it's a reciprocal sine. Secant theta is hypotenuse over adjacent because it's a reciprocal of cosine. And cotangent theta is adjacent over opposite, again, because it is the reciprocal of tangent theta. So a few things that we need to remember is all students take calculus. And in order to do these problems, I have to figure out what quadrant I'm in first. So if sine theta is equal to negative 5 over 13, that means sine is negative. If sine is negative, I'm in quadrants 3 or 4. And secant theta is less than 0, that means secant's negative, and secant is negative in 2 and 3, so that puts me in quadrant 3. So I draw my axes over here, and then I draw a right triangle, and I label my triangle. sine, so this is my angle here, sine is the opposite side of the hypotenuse. The hypotenuse is never negative. So if you have a negative value, it's always going to go on one of the legs. So I have opposite, which is -5, over hypotenuse, which is 13. And then I have to find my third side, and I just use the Pythagorean theorem. A squared plus b squared equals c squared. And it doesn't matter which is a and which is b, but 5 squared is equal to b squared. 5 squared, sorry, plus b squared is equal to 13 squared. So 25 plus b squared equals 129 or 169. Subtract the 25 from both sides, so b squared is equal to 144. So b is equal to 12. Now it needs to be -12 because on the coordinate plane, this is a negative x direction. So it's -12. And technically, if I were to make a point right here on the end, this should be the point -12, -5. Oh, now it's going to play games with me here. Okay, so -12, -5 is the actual coordinates for that point on the graph. So cosine is then adjacent over hypotenuse, so it's -12 over 13. Tangent is opposite over adjacent. Since they're both negative, it makes it positive, so 5 over 12. Cosecant then is going to be hypotenuse over opposite, so it's going to be 13 over -5. Secant is going to be 13 over -12 because that is the hypotenuse over the adjacent. And cotangent is adjacent over opposite, so it's -12 over -5. Both being negative makes it positive. And there you go. A 5, 12, 13 triangle is one of our Pythagorean triples that we should know. So if you have a 5 and a 12 and a 13, you don't always have to use a Pythagorean theorem if you know the size of the triangle. All right, if tangent theta is -1/3, so that means tangent's negative in 2 and 4, and cosine theta is less than 0, which means that's also negative, and it's negative in 2 and 3, find all the other trig values. Well, since I'm in quadrant 2, I draw my picture. Tangent is opposite over adjacent. So I have 1 and my 1's over here, my 3's over here. The 1 is in a positive direction because on the coordinate axes, going up in quadrant 2 is positive, and going to the left is negative. So then x value is negative, so it's -3. And I use the Pythagorean theorem, a squared plus b squared equals c squared, to find that my hypotenuse is radical 10. So sine is equal to opposite over hypotenuse, which is 1 over radical 10, which we can't leave, so we have to do radical 10 over radical 10 to rationalize it, so we get radical 10 over 10. Cosine is adjacent over hypotenuse, so it's -3 over square root of 10. Again, rationalize, we have -3 radical 10 over 10. Cosecant is hypotenuse over opposite, so it's radical 10 over 1, or just radical 10. Secant is hypotenuse over adjacent, so it's radical 10 over -3, so it's a negative radical 10 over 3. Cotangent is going to be adjacent over opposite, so it's -3 over 1, or just -3. Okay, for number 4, if cosine theta is equal to 3/5, it's positive. Cosine's positive in 1 and 4. And sine theta is less than 0, which is negative, so it means we're in 3 or 4. Find the remaining trig functions. So cosine is adjacent over hypotenuse, so 3/5. My third side is then 4 because it's a 3, 4, 5. As long as 5 is on the hypotenuse and 3 is one of the sides, you can do a 3, 4, 5. Sine is opposite over hypotenuse, so it's right -4/5. Tangent is opposite over adjacent, so it's -4/3. It's a 4. Cosecant is 5 sorry, negative, yeah, it's 5 over negative 4, so it's a negative 5/4. Secant is hypotenuse over adjacent, so it would be 5, that's a 3/3. And cotangent is adjacent over opposite, so it's negative 3/4. All right, that's really all there is to those, and I thank you for being patient.